I would like first to present you the institutes that I am leading. The name of the institute is Institute on Information Science and Technology, ISTI or ISTI, spelled in the Italian way. It's one of the 88 institutes of the Italian National Research Council. The National Research Council, CNR, spreads all Italian territory with different places, and we are located in Pisa. In Pisa we have a very strong hold of CNR, since we have a campus with 13 institutes and more or less 1,200 people. ISTI is the bigger one in this campus, and it's also the largest CNR institute on computer science. We have around 300 people staff, including fellows and PhD students. And Pisa is also a very nice place for doing research, because it's a small city with 4 universities and this CNR presence. So it's a city of knowledge, not just the city of the Leaning Tower. We are trying to do our best to pursue excellence in scientific research, technology transfer, and also training and education, even if we are not giving degrees or courses, but we are actively collaborating to the activity in several universities. We are active on international and national projects. In average, we have around 95 projects running in the institute every year with external funds, which totals around 5 million euro per year, and around 50%, 40 or 50% of these funds are from European projects, which we consider a very important activity, a way of establishing excellent scientific collaboration. We produce around 350 international publications per year, and we are organized in research laboratories. I will not give you the complete list, but just a very brief glance to some major activities. Obviously, we have a lot of activity on AI, both on foundational teams and on applied and transversal activities looking to other computer science disciplines. We have a very strong activity on visual technologies, including computer vision, 3D graphics, immersive technologies, architectural design, and so on. We have another important stream on system design, software engineering, formal methods, human-computer interaction. Information retrieval is another topic of interest, and obviously networking. That is not my background topic, but it's an important activity at ISTI. Considering the application domain, we have a lot of activity on health and wellness, on cultural heritage, on mobility, ecology, agriculture, and so on. So let me start presenting you the activity of the Institute. I divided my presentation into chunks. First, I will present you briefly the activity on AI, on artificial intelligence, towards different domains, but not networking. In the second part of the presentation, I will present you the material related to the networking topic. So we start with non-networking activities. As usual, AI probably had the recent boom starting from computer vision application. We have a very strong computer vision lab at ISTI, which has endorsed AI from the very beginning, and we are working now on the typical topics of understanding images and understanding the content of images. We have a very nice and successful system called Visione, which is implementing a cross-modal video and image retrieval system, in which we both consider the content of images and also textual information. Textual information that can be given by the user as queries or can be extracted in an automatic manner from images. And another topic of activity is counting. Count the number of items which are in this image, in this photograph, just to build up numerical information after you have recognized something. Extended reality is another domain of activity for AI. We are coordinating an important European project called SUN, Social and Human-Centered XR, Extended Reality, and we use AI for different purposes, also for giving the users the possibility to feel and to explore virtual objects instead of the physical ones. Some activities, some foundational activities concerning AI is focusing on the explainability of AI technologies. This is a key topic because in a lot of cases we consider AI as a black box. We trust in the quality of the results produced by AI, but we have no proofs, no clues on why and how much the results are really correct. So this group is working on explainability of the AI by following two main approaches. The first one is explainable by design, so inserting in the codes all the rules which are needed to prove by design the correctness of the activity. The second approach is trying to consider the code as a black box, but building up all the methods which allows to produce data and to verify maybe synthetic images, for example, in the case in which the code is managing images, and to verify the result in order to prove with some user studies the correctness of the results. Large language models, it's obviously another topic in which AI is a key ingredient. In this case, one very nice activity which is going on is on authorship analysis, which means being able to recognize the author of a text, taking into account books or poetry or any type of composition, of artistic composition of authors, and being able to understand if this work is due to an important writer or not. It's the topic of this activity. And nowadays it's also, authorship means also the vice versa, discovering if a text has been produced by an AI agent rather than a human, which is really important stuff, especially for didactical and also scientific uses of AI. Now, we would like to avoid that AI will wrote our papers in the near future. Information retrieval is another topic in which AI is more and more used in order to reduce the extent of computation that we need in order to solve queries. And here the goal is to maintain good latency, but reduce the size of the indexes, reduce the size of memories, and making the search much more efficient and robust, even if we are, for example, visiting just a subtree and not the entire index. Well, health and well-being are other topics very well studied, and we also have a lot of activity here. We are focusing most on image-based diagnosis and prognosis, so helping the medical doctors to analyze images coming from CT scans or an MRI images, and helping them to discover the typical sign of possible illnesses. The idea is to provide quantitative and repeatable support to radiologists and medical doctors in order to allow them to reduce errors and make the diagnosis more precise and more fast. And another similar field of activity is the one concerning well-being, mostly elderly life, in which nowadays we can dispose of a large number of sensors which can be located in homes, in every context. This sensor produces a huge amount of data which qualify the life attitude, the movement of the person, how much physical activities he is doing, possible accidents, possible loss of mental activity, and all this data have to be monitored in real time, and data have to be understood, and possible warning signals should be activated. So there is a lot of space for intelligent data analysis and for driving maybe actuators which help the person. And finally, environmental modeling. In the case of environmental monitoring activities, in many cases we start from large or huge image-based sampling of the situation of our environment. We may have a huge quantity of data coming either from remote sensing with satellites or also by using drones, both on land and underwater. And even in the image that you see on the right, you have an image of corals in the Pacific reefs. This is a highly endangered biological systems in which you have to run extensive image-based acquisitions, and you have the problems of how to understand the content of these hundreds of thousands of images. And we developed TagLab, which is an interactive AI-based solution which allows you to classify all these images in an automatic manner. So what you see, the color that you see are related to the different species and the different health state of these different species. And this can be done in a totally automatic manner, and you can also monitor, so you can compare a sampling done 2 years ago with the sampling done today, deriving numerical values. How much is the percentage of corals dead in these 2 years or in 5 years? And this system, it's highly successful. It has been, it is underused by the most important projects in the Pacific area in order to monitor this stuff. And now it's having some problems due to the American new policy over this type of activities. So our colleagues in California are having big problems, unfortunately. So let me shift from AI for many different things to AI for networking. So what are we doing? In ISTI we have a research lab that is called Wireless Network Lab, who is working on networking topics. The lab has a very nice and productive collaboration with Huawei. It's working together with the AI, IETF and ITSI, and it's mostly working on the 3 topics that you see here: networking paradigm design, NTK for analysis and design of AI-powered networking, and intent-based networking. So let me briefly present. First, let me touch what this person think is the ongoing evolution of the network topic. Telecommunication industry is evolving with the development of high-speed wireless communication. Network are now based on multi-technology integrations such as 5G and NTN, and this opens a number of issues, a number of problems due to the complexity of the different components which have to be used together in order to reach the performances that we need in this domain. The third generation partnership project is spending much effort on standardization of the new 5G core functionality and features, and features include the service-based architecture, improved quality of service, enhanced machine-to-machine communication, cloud-native technologies, and access to edge computing. In this context, AI is more and more perceived as an important, a very key enabling technology in order to improve our networking technologies. We expect that also in the telecommunication industry, the amount of money invested in AI will increase, as in many other computer science domains. And we see that there are some benefits, some potential important goals, which are mostly the improvement of network performance, the prediction of network state, and the possibility of providing models of the infrastructure behavior. So the idea is to, therefore, becoming faster, becoming more predictable, and having clones of your network, which allows to understand better the functioning of the network and to steer it. It has in many other domains in which AI is an enabling technology. We need a lot of data in order to drive the AI codes. And as in many other domains, acquiring data, it's a nightmare, because especially if you need, if you are in a real-time context, acquiring data means losing time in saving things instead of working on the real application. And this means that in networks, we should try to avoid as much as possible, to be very selective in data acquisition, and as much as possible we should be able to capture data, not introducing delays and not introducing non-negligible cost in the application. We should not perturb user data traffic, should not be a factor of perturbation, and we should be able also to address that data should come from heterogeneous infrastructure, such as 5G control plane and user plane. So, what the colleagues working on this topic are doing, they are working on network paradigms for the design of the new networks using AI. This includes working on SRv6 enabled data plane for scalable and programmable network architecture, latency-aware communication mechanism to optimize interaction among distributed network resources, in-band and out-of-band telemetry frameworks for efficient monitoring of large-scale distributed systems, and interoperability and integration with heterogeneous technologies, which is a key factor in this domain. Neural tangent kernel is an instrument deeply used by my colleagues for analyzing and design AI-powered networking. The idea is to use as much as simple solution, because especially due to the time requirement, the real-time activity, simpler is the approach, better is our capability of investigating stability and efficiency of the system. They are used to this methodology for the analysis of distributed autonomous controls and optimization system guided by information metrics. And the idea is to use this approach also to allow an easier development of a so-called digital twin of our complex network systems. Intent-based networking involves policy abstraction and synthesis into machine interpretable network rules, automated provision and configuration of distributed data plane resources, closed-loop orchestration, optimized use of resources, and leveraging LLM-driven reasoning for adaptive control, and enabling scalable, self-managing, and intent-aware network infrastructure. So the idea is to be able to also to use LLM-driven reasoning for giving insight and control and enhanced control into the network activity. You see here some contacts. The topic of AI for networking. I have with me Pietro Cassarà, that is, you don't see him, but it's in the audience. Here it is, it was covered by the curtains. Pietro Cassarà is leading these activities AI for the networking, and you have other names for other 5 major activities running on in the Institute. As I told you, AI is a really important topic. We are not an institute working on AI. We are working on many different computer science disciplines, many different computer science topics, but by the way, AI started in a couple of these labs, but now is becoming an instrument of work for most of them, and it's becoming a technology that is enabling many other activities, and so we are investing a lot, both in terms of personnel, in terms of project proposals that we are writing. It's behind a lot of activities of a national project we started 2.5 years ago in Italy, on the base of the recovery funds which have been given by European Union, and we have 22 activities on this large project funded by the Ministry of Research, and most of them in a way or in another touch the topic of AI. So it's the future, and it's something on which we are investing in an extensive manner. And this closes my presentation. Thanks a lot.